A very good evening and welcome back to Sense of Science, an educational channel where learning is made simple and fun. So the topic for today is chain rule. Now chain rule is a topic of the chapter Continuity and Differentiability of Differential Calculus class 12, and this topic itself comprises of very few questions in the book, but the use of this topic is in all the other topics succeeding this chapter after chain rule. Okay, so differentiation of logarithms, parameters, differentiations of trigonometric functions, exponential functions, logarithmic functions, all of them are using this chain rule. So if we understand this concept of chain rule clearly, we can do all the other questions very clearly. Okay, so this is the fun chain rule. Now what does chain rule state? Now see, chain rule gives us lot of formulas in terms of compositions of function, f of gx, g of gx, but we don't have to actually use them in questions. It's very simple. This is the statement you need to keep in mind, that the standard function, that means one function itself, is not given, so we will differentiate all the functions we have together. This means that in the questions for chain rule, we won't be given a single function. We'll be given multiple functions as a part of a single function, and we have to differentiate all of them together. Okay, that's our chain rule. So let's take them up with some questions of your exercise 5.2 of class 12, continuity and differentiability. So we are taking up exercise 5.2. Okay, so let's get started with the questions. The first question I want to take up from chain rule is question number 1, which states differentiate this function y is equal to sine of x square plus 5. Okay, all right. Okay, now first of all you have to identify whether this is a standard function or not. What is a standard function? A function whose directly the function is given. Now see, if I see this as a sine x, this is not sine x. Sine is a function, this is function a here, and x square plus 5 itself is also a function. So this is b. That means a function is contained within a function, and in these cases when we have a function within a function, we are using the chain rule. Okay, so function inside a function. Okay, so for this, as we just did in the statement, that we have to differentiate all the functions together, I will do that. Dy by dx, I am differentiating with respect to x, is equal to d of dx, that is a differential of sine of x square plus 5. Chain rule is a multiplication into d of dx of x square plus 5. Now differential of sine is cos. These are general formulas of class 11, should be remembered. So this becomes cos of x square plus 5 into differential of x square plus 5. 5 is a constant, so differential of 5 will give us 0. This is giving us 0. And x square, we know the power formula, that differential of x ki power n is equal to nx ki power n minus 1. This is the simple power formula which we have done in class 11. So this will be x to the power of 2, which will be 2x. Okay, 2x simply. So into 2x, and this is your final dy by dx. So before moving to the further questions, let's take up a conclusion that in chain rule I have been given functions within a function. So I'll differentiate all the functions together in a product form, and I'll get the final formula. Okay, let's move on to the next question. Question number 2. Question number 2 is saying differentiate y is equal to cos of sine x. Now if it was simply cos of x, I could have directly differentiated it using the formula for cos derivative. But cos is also a function, sine x is also a function, so I have a function within a function, so I will be using chain rule. It's very important that you see that where chain rule is used or not. In all questions you won't get chain rule. Okay, so this hence will be in a product form. I can write it as dy by dx is equal to d dx of cos of sine x into d dx of sine x. Okay, now derivative of cos from the formula which we have done in class 11 is minus sine. So this will become your minus sine x, because I am only differentiating the outer part here, into differential of sine x. Sine x differential is cos x. This dot stands for product. So hence the final dy by dx turns out to be your minus sine x cos x. Okay, This is my final answer. Please make a note so that I can move to the next question. Question number 3. Question number 3 is sine of ax plus b. Okay, so I can see there are two functions again here. I have a function a of sine and I have a function b of ax plus b. So I have to differentiate them separately using the chain rule. And this of course is equal to y. So dy by dx is basically your derivative of sine of ax plus b into derivative of ax plus b. Now a simple thing, a and b of course they are given to the question only, they are constants. So differential of sine is cos, so this becomes cos of ax plus b. Now b of course is a constant separately, so its derivative becomes 0. And the a in the constant, whenever a constant is multiplied in a differential, it is taken out, and whenever it is just simply added, it's always 0. So ax plus b, say I take out a and I differentiate x. Differential of x again is a formula of class 11 is 1. So it becomes a into 1. So it just simply becomes a cos ax plus b, or cos ax plus b into a, simply is your dy by dx. Okay, why? Because when ax plus b, if I talk about this term once again, ax plus b, I have one constant out as a sum, so its derivative becomes 0. And in ax I have a constant in a product form, so I take the constant out and differentiate x, and differentiation of x gives us 1. So these class 11 formulas definitely should be in your mind and your fingertips before solving such questions. Question number 4 now is the next part. Question number 4. I'll be doing 1 or 2 more questions. The rest of it you can try, and in case if there is any doubt, you can contact me on the comment section and I'll definitely clear them. So question number 4 is secant of tan of root x is equal to y, and I have to differentiate this. So how to go about it simply is d dx dy by dx is equal to d dx of, first function is secant, so I can differentiate secant of tan root x into d dx of second function tan root x, so tan of root x. And the third function, root x is also not a standard function. Standard function means it's x, so I have to differentiate root x also, d dx of root x. This will give me my answer. So differential of sec x is equal to sec x tan x. So sec x tan root x is sec x tan root x tan x tan root x. Fine. So this will become sec x tan x, which is a derivative of sec, into tan root x. I can even split it and write it as sec x tan root x and tan x tan root x. That's up to your choice. It's not necessary. Into tan. Derivative of tan is sec square. So tan root x be sec square root x. Sec square root x into derivative of root x. Now root x again means x ki power 1 by 2. And derivative of root x again is a formula of class 11. It comes out to be your 1 upon 2 root x. And this is my final answer as well. Okay. Now this 1 upon 2 root x comes out from your power formula. A derivation of class 11. Power formula was derivative of x to the power n is nx n minus 1. Okay. And root x means x to the power 1 by 2. So if I use that formula, I'll get this final answer. Okay. Root x means x to the power 1 by 2. Okay. And if I do that, I will get this final formula, which will be your answer as well. Okay. So I am again repeating that class 11 concept is very important. If that is not clear, then of course these topics won't get cleared easily. I'll take up one more question today. The next question is this one. Question number 7 of the exercise. I'll just change the color. So we can take this beautiful green color. Okay. Question number 7 is y is equal to 2 under root cot x square. Okay. Wait, I'll just get it like this. Fine. So this is my function. So dy by dx, again I can see that this is a case of chain rule, because 2 is a function, root of cot is a function, and x square is a function, isn't it? So I have to differentiate all of them together. Fine. So this becomes 2 is a constant, so I just take the 2 out because it's a constant in multiplication. Then I will differentiate this d dx of under root cot of x square. Now just wait a minute, I have just done this case in the previous question, so I'll just write it in a simpler way. I can write it as 2 into 1 upon 2 under root cot x square. Can I write it like this? Can I or can I not? Yes, I can, because what I have just done in this question, if I would look at this question once again, where I had to differentiate a root of a function. Whenever I differentiate the root of a function, it becomes 1 by 2 root of that function, isn't it? I just did it right now in this case. So the root of cot x square becomes 1 by 2 cot x square, root cot x square. Okay, that's simple. We just now did it in the previous question using the power formula. Into the derivative of the function inside. The function inside is into derivative of cot x square into, again x square is not a standard function, derivative of x square. Fine. So your final dy by dx comes out to be your, this 2 and 2 gets cancelled, so I get the final dy by dx as 1 upon under root cot x square into derivative of cot x is minus cosec x, so cot x square becomes minus cosec x square, again a formula of class 11, please do learn these formulas, into derivative of x square, which from the power formula becomes your 2x, okay, into 2x. And this is my final answer. Okay, so again, if you get this kind of a question, your root is the first function, the first function is root, the cot is your second function, and your x square is your third function, and you have differentiated all of them together. That is your chain rule. So as a conclusion, I can write that if we have been given functions like this, y of f of x, suppose this is a function I have been given, and I have to, this is the result I am writing, I have to differentiate it using the chain rule. So by the chain rule, I can write it as derivative of y first, derivative of y into f of x into derivative of f of x into derivative of x. Okay, this is your final conclusion of the chain rule. Okay, so what I can draw as a conclusion, if I have been given functions contained in a function, that means there is no standard single function, functions are contained in a function, I have to differentiate all of the functions separately, and that will be my final derivative. So what this comes out is my final derivative or differential coefficient. Okay, this chain rule is important as it can give direct questions, but in all the other parts of this chapter also you will get questions as well from chain rule. Chain rule application is very, very important. Okay, so with this we will wind up for today, and I'll soon come up with other questions and concepts based on differentials again. Okay, so take care till then and stay safe. Thank you.